Okay, the topic for now is IDFT through FFT. In other words, we can say IFFT through FFT. That is, frequency domain sequence is given x of k and we have to find x of n, okay, through FFT. Clear? Now, and this is the formula to obtain x of n from x of k. Formula is x of n equal to 1 by n whole brackets summation k x star of k, where k is equal to 0 to n minus 1 w n power kn, again the whole conjugate, that whole star. That means if x of k is given, what are the 4 steps? First we have to find x star of k, which is the conjugate of x of k. Then we have to find DFT of x star of k. This formula is DFT formula, and the obtained answer we have to take the conjugate again, third step, and the final step, the whole and the answer which we get in step number 3 we have to divide by n. If it is 8 point means we have to divide by 8. The 4 steps. The first step is given x of k, we have to find x star of k. Okay, x star of k means conjugate. So this is the first step, x star of k. Where and all minus is there, we have to put plus, and where and all plus is there, we have to put minus. So if here it is plus plus, we have to put minus minus. Clear? So this is x star of k. The second step we have to find DFT of x star of k, and that too using FFT. So here I have done DIT, decimation in time. You can also do decimation frequency. So x star of k. So decimation time means input is bit reversal. So 0 4 2 6 1 5 3 7 input. So x star of 0 is 12. X star of 0 4 no. X star of 4 is 0. Like that, if you find, just see that values and write the values here. 0 4 2 6 1 5 3 7. So 12 0 0 0. So here in this problem we see the imaginary part coming into picture. So far we have seen only real part. So this is a complex number which has a real and imaginary part. So a plus b. When you do a plus b here, 1 plus 1 is 2, and when you add this, j 2.4 minus j 0.4 is j2, and this point is a minus b. 1 minus 1 0, real part is 0, imaginary part, this minus becomes plus, so this becomes j 2.828. Similarly do this, a plus b, and this point is a minus b. Then as usual multiply the output of the first stage with the phase factor, we get the input to the second stage. This here, j into minus j is minus j squared, which is plus 1. 1 into 2.828 is 2.828. Be careful with j when you multiply. Then again this one, a1 plus a2, a2 plus b2, a1 minus b1, which is 12 minus 0, and a2 minus b2. And here it is a1 plus b1. When you do here, the imaginary part gets cancelled. 2 plus 2 is 4. Then this point is a2 plus b2, a2 plus b2. So here write the real part first, then the imaginary part, a1 minus b1. So 2 minus 2 0, the real part gets cancelled. j2 plus j2 is j4, and here also a2 minus b2. Be careful with the calculations. Output of the second stage multiply by the phase factor or the twiddle factor, we get the input to the third stage. This multiplication carefully do with the calculator. You will get the answer as 3.99 approximate to 4, and the final stage we get the answer as 4/16 followed by 4/8, and this we can call it as capital L, not capital X. Okay, write it as capital L of 0, capital L of 1 till capital L of 7. So the second stage output is, I am representing that as capital L. This 4/16 followed by 4/8. Third, what is the third step I told you? Just take the conjugate of this answer. Since we have everything as real part, we get the answer as the same answer because there is no imaginary part involved. Final step, x of n is obtained by dividing by n. Here it is 8. So when you divide by 8, 16 by 8 is 2, and 8 by 8 is 1. So So this is x of n, IDFT through FFT, or x of n from x of k using FFT. The problem can be asked in any way. Read the problem once, better twice, till you understand the problem, then see what is asked, then you proceed with the problem. Okay, all the best.